part 1 of this series, we discussed the most common operating principles that microphones use to convert sound waves into an electrical signal. In part 2, we learned how a microphone's frequency response affects the sound of voices and instruments. In this episode, we'll review an often misunderstood microphone specification, polar pattern. A microphone's polar pattern defines how it responds to sounds coming from different directions. The polar pattern tells you how the mic should be placed to maximize pickup of the desired sound source while minimizing feedback or pickup of background noise. An omnidirectional microphone has the same output regardless of its orientation to the sound source. Its polar pattern is a sphere. On paper, it looks like a nearly smooth circle. In this demonstration, notice how the sound level remains virtually constant even as the angle between the microphone and the sound source changes. An omnidirectional mic can pick up a group of people sitting around a table, but it can't be aimed to favor one source over another. A unidirectional microphone is most sensitive to sound coming from one direction. A unidirectional mic picks up less ambient noise than an omnidirectional type and is less susceptible to feedback when used with a sound system. The most common unidirectional pattern is the cardioid, which is so named because it resembles a heart. A cardioid microphone is most sensitive to sound sources in front of the mic and least sensitive to sound sources that are directly behind the mic. A cardioid mic has a useful pickup angle of approximately 130 degrees, which can accommodate two talkers or singers, or one user who may not always be directly in front of the mic. In this demonstration, notice how the sound level gradually drops as the angle between the microphone and the sound source changes. A supercardioid microphone has a narrower pickup angle than the cardioid, but unlike the cardioid, it is slightly sensitive to sound sources that are directly behind the mic. A supercardioid mic provides better isolation from room noise and nearby instruments, and can be more resistant to feedback than a cardioid, but it requires the user to maintain a more consistent position directly in front of the mic. In this demonstration, notice how the sound level drops more rapidly as the angle between the microphone and the sound source changes. The microphone's polar pattern affects where floor monitors should be placed to minimize feedback. With a cardioid mic like the SM58, the floor monitor should be placed directly in front of the mic stand. This way, it is aimed at the least sensitive part of the microphone's polar pattern. If the same monitor speaker placement is used with a supercardioid microphone, it will be facing the sensitive area at the back of the supercardioid pattern. Feedback will probably be worse than with a cardioid mic. With a supercardioid mic like the Beta 58, floor monitors should be placed slightly to the sides of the mic stand. This way, they're aimed at the least sensitive part of the microphone's polar pattern. This arrangement allows a supercardioid mic to deliver more gain before feedback than a cardioid. A bidirectional microphone is equally sensitive to sounds coming from the front and the rear of the mic, and least sensitive to sounds coming from the sides. Bidirectional mics have a very narrow pickup angle. This makes a bidirectional mic useful for isolating one voice or instrument that is surrounded by other sound sources, as long as there is nothing directly behind the mic. In this demonstration, notice how the sound level drops off dramatically when the sound is coming from the side, but returns when the sound is coming from the rear. The microphone's polar pattern affects not only how it picks up the sound source, but also how it behaves in a particular room or with a particular sound system. By understanding microphone characteristics like polar pattern, you'll be able to choose the best mic for any application and get better results when recording or using a sound system. In Part 4 of this series, we'll discuss how the electrical output of a microphone relates to the sound source and the mixer or recording device.